Hello there, function folks. We're back with some more Trig fun, 3.3. Uh, Last day we were drawing some angles in radians, and I'm hoping that more and more we're thinking about these sorts of things, angles in radians, that we're not always converting back to degrees. Now, we'll let it slip once in a while, this degree business, but we want to think more and more in terms of radians. So in this case, 3-minute review, straight from yesterday's stuff or last day's stuff, draw each angle. So 5 pi over 4. How are we going to figure out where this is? Well, hopefully you remember that the straight line is pi, right? That's an easy one to remember. There's 0, and we're rotating around. And so we want just a little bit more than pi. Now, pi is the same as 4 pi over 4, right? So we want another pi over 4, which is going to be here somewhere, right? And so if I think of this, and we mentioned yesterday, one of the advantages of radian mode is that I can see the related angle really quick here. The related acute angle is pi over 4, and so this little bit that's extra is pi over 4, and there's 4 pi over 4, 5 pi over 4. So there's 5 pi over 4. Another way to think of this is, and this is one of the things we were practicing yesterday, was counting in related acute angles. So, for instance, pi over 4 we think of as the 45-degree angle, which is kind of that much, right? There's pi over 4. Then 2 pi over 4 was the same as pi over 2, or the same thing as 90 degrees. And then there's 3 pi over 4, 3 pi over 4, 4 pi over 4 we mentioned already, and there's 5 pi over 4. So we can practice it, our fraction counting in radians. This one, 3 pi over 2, we think of the related acute angle, and it's not really an acute angle, isn't it? This pi over 2 is, that's our 90, right? So there's pi over 2. There's 2 pi over 2, which is just pi. And then there's 3 pi over 2, right? So this angle is 3 pi over 2. Or we could think of this as 390s, which is 270 degrees. No problem. Angles drawn. End of the 3-minute review, and on to today's fun trig stuff. Trig ratios of special angles. You had a lesson or two in grade 11 MHF4U that was titled this, but it wasn't find trig exact trig ratios of these angles. It was of 0, 30, 45 degrees. These are all degrees. 60 degrees and 90 degrees. So this is actually a review lesson, even though I'm going to, of course, like everything, it feels like we have to put a little rest-all spin on it. So depending on who you had in grade 11, you're going to have different ways that you'll remember these ratios. These are the ratios of these angles, but we're going to think of them in terms of radians. Probably most of your and by the way, we're not going to talk about where these come from. We're just going to review them. Probably where they came from in grade 11 was from these special triangles, right? This is what we would think of in grade 11 as a 30, 60, 90 triangle, right? And then you had to remember the sides. This is 2 and 1 and the square root of 3, rather, square root of 3. And this is true this year too, except for this isn't the case anymore. We're not talking degrees, we're talking radians. So this is pi over 6, and this is pi over 3. And then I can start talking about the ratios of these angles. So for instance, if I wanted to talk about the sine of pi over 6, I know it's opposite over hypotenuse, 1 over 2, and I knew that exactly. Well, last year this was 30 degrees, but now it's sine of pi over 6. And the other triangle would be the 45, 45, 90 triangle, which, if you remember, hopefully was 1, 1, and square root of 2. And again, 45, no, not 45, undo. undo, not 45. It is a pi over 4 angle, right? That's what pi over 4 is 45 degrees. And that was the case. So if I wanted to do the cosine of pi over 4, then it was adjacent over hypotenuse. Adjacent over hypotenuse is 1 over the square root of 2. And I know it's adjacent because of SOHCAHTOA. This is where trig started for us. It's came a long way since SOHCAHTOA, but it's still true here, right? The cos of pi over 4 is adjacent over hypotenuse in this special triangle. Okay, and so probably the way you learned in grade 11 is to memorize these triangles and then be able to reproduce the sine and cosine and tangent. What I'm going to do is I am going to put this all on a summary chart. Okay, so this was a summary of grade 11 stuff. And if you can't remember this from grade 11, well, that's okay. You're going to start remembering it in grade 12. All right, this is 0 radians. 30 degrees we said was pi over 6. This was pi over 4. And this was pi over 3 and pi over 2. And I'm just going to clunk these off of here into my summary. All right, so sine of 30 degrees is opposite over hypotenuse. The cosine is adjacent over hypotenuse, square root of 3 over 2. And the tangent is opposite over, okay, and then 45, 1 over the square root of 2, and cosine's the same, adjacent over hypotenuse, and the tangent opposite over adjacent is 1 over 1, or just 1. 60 degrees is opposite over hypotenuse, square root of 3. 1/2 for the cosine, adjacent over hypotenuse, and then tangent opposite over adjacent is square root of 3 over 1. Dandy. Now, how do we remember these? Well, we could clunk it into a calculator, but there's a better way. Remember what we know from the unit circle. The unit circle is great for these special angles. So I'm going to talk about the two special angles, which are 0 degrees. Right? So here's a rotation angle of 0 degrees. And remember, that point right there gives me the cosine of the angle, well, 0 here, and then the sine of the angle. X is cos, y is sine. Well, what's the coordinates? It's 1 and 0. So the cosine of 0 is 1, and the sine of 0 is 0. So the cosine was 1, and the sine was 0. Well, what's the tangent? Well, the tangent, remember, is just tan theta is equal to y over x, and in this case, 0 over 1, which is equal to 0. And if you don't trust me, you can use your calculator if you don't trust me. What about a 90-degree angle? Well, there's a 90-degree angle. So where the terminal arm crosses the unit circle, that gives me the cosine and sine, and the cosine is 0, and the sine is 1, and I get the sine is 1, and the cosine is 0. And the tangent is kind of weird here because the tan of 90, no, not 90. Let's get used to this. The tan of pi over 2 is y over x, but in this case, I get 1 over 0, which is, that's bad. Error. We actually don't call it error. We call it it's undefined. And so I'm going to record that in this summary chart as undefined. I'm just going to put 2 little slashes here. Okay, these you have to commit to memory, either on the triangle or triangles, and then you can come up with them, or my favorite way, and this is kind of is I memorize this chart. Yes, I memorize this chart, and I'm going to help you with a little trick to show you that in just a second. I want to show you a different way, though, and this was on a sheet that I handed you, and it's on this handout, is that here's all of the ratios on one picture, right? So here's a rotation angle of pi over 6, and remember, cos is x, so this is the cos of pi over 6, and this is the sine of pi over 6, right? If I ever wanted the tangent, I just put y over x. So I put 1/2 over the square root of 3 over 2, and then I can simplify that. The 2's cancel out. 1 over the square root of 3. Okay? Now, what's strange about this, the 45 one looks weird. See that? That looks weird. So we would expect the sine of pi over 4 to be 1 over the square root of 2. But it's a math thing to not have any roots on the bottom of numbers. And so if we multiply by a convenient form of 1, square root of 2 over the square root of 2, what do I get? Square root of 2 times the square root of 2 is just 2, and these are equivalent forms. I'm okay with you writing that. You'll see this in a lot of textbooks just because they have what's called a rational denominator. Okay? All right, so if you prefer this unit circle, that you remember that all the values from the unit circle, you're welcome to remember it that way. I, oddly enough, like I said earlier, I memorized this table. I said, how on the earth can you memorize this table? Well, you can see some of the patterns, right? They're kind of, this way is one way and this way is flipped. And then tangent, well, tangent's weird because there's square roots all over the square roots of 3's instead of square roots of 2's. It's a, it's odd, but I memorized this, and there's actually a trick. And here it comes. I'm going to do it on a new page. This is kind of a memory tool. This is how Restall remembers all of the... I set up a table, all right, with all the values, 0, and you got to remember these. I suppose that part you have to memorize. Pi over 6, pi over 4, pi over 3, and notice the fractions, the numbers on the bottom are getting bigger, so these angles are getting bigger. Sine starts at 0 and goes to 1, right? And that part I guess you have to remember, but it's pretty easy to come up with for those reasons over there. Sine starts at 0 and goes to 1. What's halfway between there is a half. What's halfway between 0 and a half? It's a quarter. What's halfway in between a half and 1 is 3/4. Okay, there are the numbers. Well, no, they're not the numbers, right? Those aren't the numbers. These are the numbers. Well, all I have to do now to get the numbers that I actually want is to take the square root of everything. Okay, square root of 0 is 0. Square root of 1 is just 1. Square root of 4 is 2. Square root of 1 is just 1. Square root of 2, well, that's the square root of 2. Square root of 3 is the square root of 3. Square root of 4 is 2. Square root of 1 is just 1. And look, there's the numbers. There's the numbers. All right, so let me do it again with the cosine line. Cosine line. Start at 1, go to 0. Halfway between is half. Halfway between here is 3/4. Halfway between here is 1/4. Now take the square root of everything. Square root. Square root of 1 stays there. Square root of 4 is just 2. Square root, square root, square root of everything, and there are the numbers. Okay? What about the tangent? How do I get the tangent line? Well, remember, this is one of the formulas from grade 11. Tan is just sine divided by cos. So I got the sine and the cos there. That's why I put them in that order. 0 divided by 1 is 0. Here I have a half divided by the square root of 3 over 2. Well, flip and multiply. I'm not going to have to do this many times before I see it. The bottoms actually cancel out, and then I'm left with 1 over the square root of 3. 1 over the square root of 2 divided by 1 over square root of 2, that's a number divided by itself is always 1. Here the bottoms cancel out, and I'm left with square root of 3 over 1. 1 divided by 0 is undefined. All right, well, there's my table, and I'll do it again in a second. I'll let you, you should pause the video and see if you come up with this table on your own. I'm going to stop there and pick it up again in the part 2.